Hello, Flat Earth researchers, debaters and debunkers. Oh, good morning. Who's that? JD. I haven't got my glasses on this wet and windy morning at Portishead in the UK, where we have massive tides of at least 10 metres or so. And it's just one of those examples of how the twisted moon gravity globe earth logic does not fit with our reality. Of course, we all know that the heavier, the more mass something we are told that this weight, rather than just being the fact that you have dense objects in the medium of air. Hi, Plane Ranger. Is caused by this magical force of gravity, which of course you need to invoke if you are to believe in the physically impossible scenario of sticking to the outside of a spinning ball. But of course what we have is this ridiculous notion that the moon, being another body of mass, a satellite of mass around a globe Earth. Okay, David Weiss, how you doing, man? But no, wait, hear me out. This is going to make so much sense. Oh, Celine Dion, hi. Body back, all right. So, just to reiterate, of course, you know, the idea that we've got gravity creating weight on the Earth is obviously a necessity of the model, because otherwise it would be physically impossible to stick to the outside of a globe. Then we have the idea that the moon is creating tides, and of course we ask the question, why don't smaller bodies of water such as lakes have tides? And the response, of course, is that you have, the more mass that you have, the more easily the moon's gravity then pulls that mass. So that's just so illogical. It does not fit with our reality at all, does it? Because, you know, the more mass something has, the heavier it is, and the more difficult it is to move. Yet we have this idea that in order for tides to occur, the more mass of water is more easily moved by the lesser gravity of the moon. It is so it's insane. What an insane you know, way of thinking, to, you know, this kind of stuff that's made up to go with the globe model, Okay, I lost you all there for a second. Yeah, it is insane, isn't it? And of course, you know, these are the kinds of things that we've all already worked out and thought about, and when, you know, but it's not often said. So I just thought it was worth putting out there, you know, so it's as a reference. And no doubt some glober will come and do some hit piece and say that I'm being ignorant, ignoring the fact, blah blah blah, which of course we all already know. But if you just again think about this ridiculous scenario, that the more mass something has, the more difficult it is to make it move. So it is absolutely ridiculous to completely reverse that and then assume that you only get tides when you have a larger body of water, therefore more mass. Absolutely ridiculous, isn't it? Oh, hi, Flat Earth Aussie, Jesus. Good to see you still pumping videos out, my man. I know, we see it a lot, don't we? People, we sometimes we get a bit tired of doing the vids and take a break and say, oh, I've had enough now. But it's just one of those things you can't help coming back to, because you've got so many ridiculous arguments out there, and so many people that are just repeating these assumptions that we've all debunked many times in all of our different videos, but of course has to be repeated until it gets through to these thick noggins on what they believe is a globe Earth. Who's that? Salute, bro. It's all over there when you go. Yeah, it is. My hands are freezing, and it's certainly taking some getting used to compared to the sunshine I'm used to getting. But it's a bit of an adventure at the same time. The green Boris chops. Yeah, so I'm not going to spend too long on this stream. I thought it would be just a good opportune moment to point out that ridiculous fallacy. Sorry, I had to get some shelter. So sorry about that. Are you still there? You're still there? If not, I'll just end the stream. Anyway. Okay, sweet, back on. Okay. All right, so, nothing more to add, really. I just got cut off before I had a chance to close out the stream. So, flat don't care about the rain. Yeah, we're out there. We're getting wet and rained on for the cause. Yeah. So just these things are worth pointing out. And so, hi, Rune Torsen. Again, it's funny, isn't it? We see lots of these channels, globagandist channels, and all any of them have is the hit pieces. That's all they have. You go and look at some of these channels, and all they've got is hit pieces, rather than actually coming up with the proof of the globe to end it all. All they can do is ridicule and conduct smear campaigns, which is, of course, what we see in the media all the time when someone is getting too close to the mark or is a threat to the status quo or the establishment. It's a shame that it's taking so long for people to get it, and they're still repeating the same old arguments. And someone on my channel today arguing about radar, and it's just that you just got to look into it. Things like that, look into it. Research. Look into it, and you'll find out that, for example, radars can often see farther than they should on a globe, but also there is a limit to the distance a radar can see, because you have to rely on that information coming back to you. And it's no different to when we look and make an observation and we have the light coming to our eyes from the distant horizon over there, which you can probably hardly see because it's such groggy weather. But that's the thing, isn't it? The closer to the surface you are, the more distorted the information becomes. That information is light trying to reach our eyes. Everything we see is reflected light. So that information gets distorted, especially close to the surface, because of all the temperature fluctuations, and you've got an air that's full of vapor and what have you. And if you look into the longest microwave link, I can't remember how long it is, but it's at least 100 miles, I think, and it's not that high up. But you could argue till the cows come home about this thing going up and seeing above the curvature. But if you go and research the information and the data for this microwave link, there are a couple of reasons they want to make it high. And one of the reasons is because microwaves do not travel very well close to the surface of water. it simply distorts the signal. So, and microwaves are very strong, but their signal will become distorted. So it's just natural on a level Earth that the higher up you get away from the distortions of the surface or near the surface, then the clearer your signal is going to be. It's simple as that. And if you look at the measure, the data on the website about this world's, just look it up, world's longest microwave link, and they stuck it on some kind of hillside and sent it down towards a town. Yeah, the data on there where they have the elevation is they had to make this microwave link quite high up because they wanted it to go above other hills and mountains, so just had to be high up. And then you'll see from the data that they've turned into this kind of landscape graph, or cutout of the surface of the Earth. There is no curvature. Of course, they make these kind of diagrams where it shows this signal going down across this bulge of curvature on a globe Earth, but then the actual data that they use shows this microwave signal going across a level surface. So, what's that? The water is on the side of a ball. Yeah, I know. It is the simplest, it is the most simple thing. And that's the thing, I think it's very important as well, not to get distracted by all these arguments. If someone comes up to you with an argument about this or that, tech or practical examples, you just say, well, go and research it and make no assumptions, and you'll see for yourself that there is never any compensation made for curvature ever in anything we ever do on the Earth or above the Earth, whether it's navigation or aviation, or engineering, none whatsoever. When they make observations, of course, perspective governs any observation, no matter what. But actual physical, tangible measurements are always done using a level Earth. And of course, when it comes to big projects, some people might argue about the LIGO facility, and they had to make it straight, and they had to compensate for the curvature of the Earth. Again, this is something that you might well be, you could incorporate a fraction of an inch or a few inches into the architectural plans, the designs of something. But when it comes to the practicality of actually building something like that, whether it's a bridge or a tunnel, then you are going to do it piece by piece, segment by segment, and you're going to line everything up with your starting point, regardless of any assumed shape of the Earth. So that's how it goes in the real world, and it just doesn't happen that we do anything related to being on a spinning ball, does it? We all know that. So anyway, just to reiterate the point I was making here we are with this massive tide. The tide's high at the moment, but it goes down at least 10 meters several times a day. It doesn't matter whether the moon comes overhead or not. But the point is, the real twisted logic of the globe is that the more mass something has, the easier it is attracted to the Earth, which makes it, gives it that, what's the word? Where you can't push it, you can't move it. Yeah, so the more mass something has, the more difficult it is to move with an external force. And we're told that the more mass something has, the more it is pulled towards the center of a globe Earth. Yet, when it comes to talking about tides and only the seas experiencing tides, the excuse given, which is a total twisting of the logic anyway, is that you need more mass of seawater to be moved. The seawater doesn't move from the gravitational pull of the moon until there's a lot of it, a lot of mass. Ridiculous. So we've got this idea that the more mass something has, the heavier it is on the Earth, yet it's not until you have a lot of mass of water that you'll start to get tides, apparently, on the globe Earth. Absolutely ridiculous. So, yeah, a bit difficult to read the comments here. I'm going to just sign out now, and appreciate you all for coming along. Thank you for sharing this this wonderful weather. But my hands are starting to freeze, and I can't do much anymore. So thanks a lot. Take it easy, and we'll catch up soon on this lovely stationary planar Earth. Have a fantastic day wherever you are and whatever you're doing. Cheerio.